Hello, everyone. It's a pleasure to be again here at the Shaw Workshop. I know that this workshop it's reaching all corners of this globe, and I'm very happy to share a few ideas with you. So, Sophie, thank you for the invitation, and I'll try to do my best. Sophie asked me, "Can you present something related to astronomy education in practice, and how you can engage your audience?" So I thought a little bit about what I was going to share with you, and I chose 3 projects that I'm really in love right now, and I hope that you will agree with my choice and that they can be beneficial to you. So I will share my screen, and I will start with this presentation of a project that is called Astronomy at My Backpack. So this project was born many years ago. It was here in my heart, and with the wish that one day I would see it come true. Actually, there were a few versions in the past in the framework of the Galileo Teacher Training Program, but it was not exactly as I wanted it to be. So, as many of you know, I had the privilege of receiving the Astronomy Education Award of the IAU that was delivered to me by Evine van der Schweck. And I promised her that I would make very good use of the prize, and that I would materialize my dream, I would make my dream come true, and finally produce the Astronomy at My Backpack. So this is what we've done. It's almost 1 year since the award was given to me, but you know, these things take their time. And what I'm going to present to you is not even the first version of the backpack. We are still on ground zero. We're just crawling. We're not even walking yet. But we're trying to put together a few things, and thinking what's the best way to provide opportunities for everyone, regardless of where on Earth they are. So to give you an idea of the backpack as it is right now, it is gathering several activities, hands-on activities, really things that you can touch with your hands. There is also some digital simulations. The backpack comes with a pen drive that has some simulations, the explanations on how to run these activities, and there is also a microbit package there. That was assembled by my team at our makerspace that is called Change Makers, and it has a microbit, a little microbit. I don't know if you all know what it is. It's a little device that allows you to connect several things. In this particular case, it comes with an USB connection. It comes with a mini breadboard, some jumpers, some LEDs, some resistance. And the idea here is that you can program this microbit, and you can, for instance, measure the luminosity of the room where you are. Very good when you're working on fighting light pollution. Or you can work on sound or acceleration, or which direction some object is going. So you can use the components of this kit. You can acquire more, and you can connect it to sensors that measure the sound, or that measure the air, the components of the air, or I don't know. As you can imagine, it has many features that we will be sharing with the people that have this kit. And the activities per se, they go from very basic astronomy, like the solar system, the sizes and distances in the solar system, and beyond. So I will go through some of these activities while I present how do we engage the audience while using or presenting this material. So this backpack will hopefully be ready by summer next year, and I hope to be able to have a few samples to distribute to some of our friends across the globe. But it would be very nice if you can provide some feedback on what you see and what you hear from me today. So The backpack was the first flight of the backpack was a couple of weeks back in Maranhão, Imperatriz, in Brazil, where there was the first Congress, International Congress of Astronomy Education in the region, and we had the opportunity to bring the backpack as it was at the moment and deliver and share with the audience. You can see the audience here. And we collected some very useful and valuable feedback. And we are going to be using that from now on in our post-production efforts. So how do you engage your audience, right? So how do we do it usually when we are delivering something like this? How did we do with the team that we had there in Imperatriz? So the idea to when you engage your audience, the first step of every activity that you do, being it a workshop with students or you're training teachers or you're engaging communities, is to get to know your audience. Okay? It's nice to meet you. I want to know who you are. So give them some minutes of attention, of highlights, so that you can understand who they are, why they are there with you, what are the main objectives, and if you are invited to go there by someone, and so you know what this community is, what are their needs, get to know them a little bit better, listen to what they have to say, look at the non-verbals, and try to figure out how you can better engage them in the activity that you are about to organize with them. The next step is you have to attract the interest of your audience. How do you do that? I don't know. It depends. For instance, I can attract your interest by asking, do you think that the Earth seen from the moon has phases? Many of you know the answer. I know, but not everybody does. And the moment you ask this question, people will be waiting. Okay, will she answer that to me? So whenever you are delivering any lesson, any activity, spark the curiosity of your audience. Have them make them curious about what you are about to present. So the results are going to be far better, for sure. And the next step, what you have to do is you have to involve them. It's not you just talking to them. You have to ask them, what do you think? Bring them back to their comfort zone where they feel, okay, I know a little bit about this and I'm curious about what you just said. And I have some ideas here, but I am not sure. So discuss with them, have them speak out loud what they think about the topic. Is it possible that the Earth has phases? Is it not possible? If it does, why would it have phases? Or why wouldn't it have phases? So ask, engage, involve, co-create this with them. The next step, of course, is to help them during the process. So what kind of experiment am I going to do? For instance, in this particular case, was not the phases of the Earth, of course. This was about an activity that was created by Leonor Cabral. By the way, I have to go back a few slides. I think I forgot to show you Leonor. Leonor, this icon here is Leonor Cabral, who is the brain behind many of the activities that are presenting here to you. So I have to thank Leonor for introducing me to this world and making me completely addicted to this kind of activity. So this is another one that she created that we use to help the students understand the solar eclipses. So if you look here, we have the sun. Of course, it's not the sun. It's something that we can buy in shops here in Portugal that we use to simulate the sun. And we have here the Earth and the moon. And if you walk far from the sun, if you put the sun at a certain scale, and you put this in front of your eye, of course, the Earth is connected to your eye, and the moon will be right in front of your eye, it will cover the sun. And this is a very nice experiment when you are discussing eclipses with your students. So you might, start by giving them these three elements to scale and say, do you think it's possible to have an eclipse of the sun like this? I mean, look, the moon is so much smaller than the sun. And so discussions can go on if you start with something like this. Of course, other ideas are possible. You can discuss with the students, for instance, constellations. What is a constellation? And actually, in Imperatriz, we had such a nice event, and we had the opportunity to discuss many concepts and how they are differently perceived by different cultures, and how you can go from the local culture to, you know, what you're trying, the concepts that you are trying to deliver, trying to respect the reality and the social and cultural environment of the audience you're working with. So in this particular case, you can invite the students using this image to create their own constellation or present them other views rather than the Western known Orion constellations, for instance. This is the Arabic view of the Orion constellations. There are others, other interpretations. You can show them, you can give them a sense of distance of the different stars and show them that in a constellation, some stars are closer to the sun than to the other stars of the constellation. Or you can go more in depth and discuss what is the definition of a constellation nowadays by the International Astronomical Union. You can even open, for instance, the Worldwide Telescope and go investigating that the objects that are in the region, and, you know, ask them, go take a picture with a robotic telescope, investigate more, discover what scientists know about this object, using, for instance, the Fox telescope or the Las Cumbres networks of telescope, or go explore what, for instance, scientists have discovered about this object. So these are things that can take you from a simple drawing that the students can make and create even their own mythology about that particular collection of stars, to the awareness of where they are in the sky, how far they are, that they are in the past, and what we know and what we don't know about them, all the riddles that are there in the sky for us yet to discover. Then help the audience in acquiring data. You have to help them. How am I going to build the experiment that will help me validate or not my hypothesis? Students will always need help on that. So you might, for instance, choose to provide them with multiple hands-on activities, depending, of course, on the topic that you are developing with them. So in this case, I'm showing another product of the backpack, which is the solar system to scale, or the distance to scale in the solar system. So students can think why they can see clearly the moon and the sun, but not the planets. They appear like stars. Why is that? Why do I see them sometimes in the sky? Sometimes I don't in the night sky. Sometimes I see them when the sun is rising. So these discussions you can do with them by providing them the lab that they are going to use to acquire their data. Or, for instance, you can invite them to understand the scales in the solar system, talk about eclipses. Why do we have eclipses? The eclipses, do you think that eclipses occur only on planet Earth? Can there be eclipses somewhere else in the solar system? So on and so forth. These are all materials that are part of our backpack. Or you can just distribute the planets according to their position to the constellations, so that they will understand that they are not aligned as we see in the pictures. They are in different places, although they are all more or less in the same plane. So, you know, you can discuss the planetary dance. You can use the planetary calculator to have them, these are all materials that are going to be in the backpack, to help them understand the movement around the sun, of the planets around the sun. So you provide them the tool, and they will play, that you teach them how to use the tool, and then they will play with them and try to come out with some answers. Of course, you can also apply the use of digital tools. It doesn't have to be only hands-on. You can combine hands-on with digital tools. There are so many simulations are there that are unique. For instance, Stellarium. I know that most of you probably know how to use Stellarium. And yes, the Earth has phases. But instead of giving this information to the students, you invite them to go to Stellarium, to put themselves on the moon, and to look to the Earth, have the days passing by, and see if the Earth will exhibit phases or not. And if so, how long would it take? So these are things that the students can do by using some models in their hands, or visual simulations, or both. It will greatly enrich their interaction with this. For instance, if in this particular case, I have used a mirror to work online with some educators to help them understand the phases of the moon. It's another piece that is going to go into the astronomy at my backpack. You can also choose to explore the moon by using a genially. So let me stop sharing my screen here. And I'm going to find here, and I'm going to share to, sorry, I am going to go back to Zoom here. And now I'm going to do something different. I'm going to share with you my complete desktop. So here it is. And I hope you are seeing my correct desktop. No, apparently not. I'm going to stop sharing again. Okay. And I will share them one by one. I will share my Genially. So this is Genially. It's an app that exists, and you have a free version for teachers, where I am working with students from 7th grade, exploring the phases of the moon. So besides playing with them with the phases of the moon that I just showed you in my PowerPoint, I'm going to invite them to think more in depth about it. Okay, so I'm going to use Genially. And what's going to happen here is that I will invite them to observe the phases of the moon and put it in a calendar. And I will invite them to explore it further. I will ask them one question and provide 3 different answers that will let me know if they have good knowledge about the phases of the moon, if the knowledge is so-so, or if they are advanced. And according to the answer that they choose, for instance, if they choose this one, they will go to a different activity, okay? And in this particular activity, they are invited to use another simulation or to use something hands-on. Imagine that they gave me something, some information that I didn't actually think is the best one. So they will take the whole pair to learn, and then they will have to answer another set of questions. And from that, I will know if they actually move forward in that application. I'll stop sharing again, and I will share with you another tool that we are using. And in this tool, and I have to share the sound, we are inviting the educators to do something a bit different. We're inviting them to use something that was created in this project called Design CT, where we can integrate artificial intelligence. And this is also related to the moon phases. And this is a very accessible tool because, first of all, I can click here and I can choose one of these languages, and the teacher can copy this and activate more languages, and they will be automatically translated. Some translations are perfect, some are not so perfect as this. I will show you just a little bit of this activity so that you understand the power of it. So take a look.
The moon has many phases but only one face. Warm up. Take this short quiz to start your journey to the moon. How often do you observe the night sky? Day. Can we see the moon in the sky during daytime or only during nighttime?
And
The
this
moon.
one, as
Initial reflection.
I will just quiet a little bit, and I can invite students to go to a Padlet and feeling something there. I can invite them to do some activities. And the most fun part is that in order for me to create this, I have here my back office, and I will show you how I have created it. So these are blocks of information that we put together here. And I can use artificial intelligence. So these are some explanations for the teachers that might require to use. And I can create this by clicking, for instance, here and asking Express GPT to help me with a summary, with quotes, with questions, with flip cards, with key points. And I have created this mixing information that I input and some information that the system helped me with. And the whole design is done by the tool itself. The whole design is not mine. So these are things that I integrated a Padlet, a learning app, a Genially. I've integrated many things in this lesson in order to enrich. So as you can see, there are multiple ways to engage your audience. I will stop sharing and I will go back to my PowerPoint, hoping that I didn't exceed my time yet. So then the next step, what we want to do, sorry, we want to do with the students is to make sure that they are able to reach a conclusion and compare to their initial thoughts. So I provide hands-on activities, simulations, things that are more advanced, where they can play and put their ideas and work with others online or offline. And with this, I can enrich their experience. And after that, the students make their conclusion, and I invite them to discuss and present the results. So they talk to each other. And if the teachers are working with us in this, I do the same thing. I invite you to do exactly the same thing, right? So they have this genuine experience from, I am very curious about something. I made my hypothesis. I think I know about this topic, but I'm not sure. I explore the topic in different ways, and students might prefer or have the need to explore it in different ways, with a video, with hands-on, with the simulations, with experiments. And then they conclude and they will present their conclusion. And through that, the teacher is collecting lots of feedback on what are the concepts that the student understood and which are the concepts that need more investment from the part of the student, and what are the types of tools that the teacher should use for the student to enrich or reach out to the desirable level of knowledge about a specific concept, while improving their competence profile greatly. And so I think this just is, sorry, I know it was very short, very compact, but this is how we are doing, this is how we are producing our resources to make sure that we can accommodate the needs of every educator, and that every educator has the possibility to accommodate the needs of every student that they have. I leave you also a link to this AI platform that I presented to you. You can take a screenshot of this. If you need more information, you can always contact me. And by the way, this one that I presented earlier is from a project called Discovery Space, and it's work in progress. It will be delivered to the hands of teachers also in the next school year, where we are mixing conversational agents with artificial intelligence, with an objective of improving the way teachers assess, validate, and lead the way of students to improve their learning. So these are all goodies that are coming your way or are already there. And I hope these are all beneficial to you. And I end by leaving you here my contacts. I will try to be online there with you when this is being presented. So if I'm here with you when you see this, it's because I managed. If not, you have my contacts here. Please let me know what you think. Leave me your wishes, and I hope that this will be in accordance with what was expected from the audience. And I leave hugs and kisses to everyone. And thank you very much for listening to me. And I think I end my recording here. Thank you.